So arithmetic series really quick, and I will use this as an example. 3 plus 5 plus 7 plus 9. This is the one we looked at. We got 24. We're going to use this kind of as our basis for looking at this. Arithmetic is a series that is adding. You are adding a common difference. There's a difference with geometric. We'll look at that at the second part of class today. So if you look at this, what's the common difference between these? 2, right? We're adding 2. Okay. All right. Now we're going to look at the derivation of this. We're going to look at it in 2 forms. We're going to approach it algebraically and also using a picture, because I think the picture helps. So let's do the graphical approach first. So graphically, I'm going to draw what you had in problem 87 with the rectangle.
What does that say on top of graphical?
Derivation. So this is kind of how we derived it and came up with it. And I like their visual approach to it because it makes sense, and it helps connect to what Gauss was doing. So this doesn't have to be perfect. 1, 2, 3, 4, 5, and 6. Struggle. Okay, there we go. 1, 2, 3.
So how many just total?
How many was there total here? 12. It was a 4 by 12. 3, 5, 7, 9. And those are the numbers. And then what they did, and this could kind of be a sketch. Don't worry if this is perfect. But then they shaded it in.
Oh.
You guys remember just seeing this? It hasn't been too long. All right. So when you solve for this, so when they gave you this picture, this rectangle has what dimensions? What's the length and the width? It's 4 by 12, and that gave you 48, right? And then what do we do to figure out the sum? We halved it. We did 4 by 12 over 2 equals 24. And that's what you see that's shaded. Now the questions become, if this method works, where does the 4 come from and where does the 12 come from? Okay, Kelsey.
Doesn't the 12 come from like the pairs that we did?
Exactly. So the 12 comes from the pairs. So be more specific here.
The 5 and the 7 equals 12 and the 3 and the 9.
Or the 3 and the 9 equal 12, right? It's going backwards. First term, last term, or coming back this way. So we can say this. Our first term, which we're going to call A1, plus our last term, which we can call A of n, times, what did 4 represent? 4 represents what? Where did the 4 come from? The number of terms, we're going to call that n, all divided by 2. And I should probably connect this to the actual problem. It was 4 times 3 plus 9, all divided by 2, because you have pairs. So that more directly connects to this problem. This is your formula for any sum. Okay? So I guess that's the graphical and the algebraic. On the right side, what I'm going to do is I'm going to write the formal definition. So you have it. If S, which means sum, is equal to A1 plus A2 plus blank, 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 all the way to AN, then the sum S is this. And this will be an equation you just have to memorize. I'm not going to make you derive it. Just memorize it. A1. Oh yeah. A1 plus A2 plus blank 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 all the way to AN all over 2. Here's your formula. Super important. And let's kind of make a key for this, what each of these terms mean. A1 represents what? First term. AN represents our last term. And N represents the number of terms. You guys learned this last year with Frank? No? All right, so here it is. This is going to go on the bottom. Did you say thank you? You're welcome. You won't be telling me thank you after I'm done with it.
This goes on the bottom.
Yeah, this goes on the bottom. Arithmetic series, and this is specifically applications. Because otherwise it's just way too easy to plug something in. Now, here's what I'm going to give you. I'm going to give you some information. I'm going to tell you that the sum of an arithmetic series is 965. So already starting different. You're not finding the sum. I gave it to you.
Woo, yeah.
The fifth term in the sequence is 29. And the 13th term is 57. Question you need to answer is how many terms in the sequence or the series? Okay, so we know that sum is equal to n a1 plus an over 2. Good, starting off strong. 965. Do I know n? N is what I'm solving for, right? How many terms? That's going to be my n. Do I know my first term? Do I know my last? No. We don't really know much of anything, do we? Okay. But we do know what two terms are, right? And now I'm going to kind of help you think about this a little bit more. I want you to sketch a graph. Kelsey?
You know how to put the top?
Okay. It forms a line, which means 529, when your fifth term is 29, that's actually a point on the line. And 1357 is another point, which is actually very helpful for us. And we don't know how long this line extends out because we don't know when it stops. But at least we know 2 points. We know that this is 529, more or less, and this is 1357. Find our slope. And I'll mark here what our goal is. We want to find what our first term is. So if it's on the same line, we can work backwards to figure that out. So let's go ahead and find our slope. And Megan, that was great to notice. Your slope is your common difference. It's the same thing. When you're done with finding your slope, check with your neighbor. So our slope is 3.5. All right. That's helpful, but it doesn't tell me what A1 is, right? So how can I find, we've been working to find our first term, right? So let's go to step 2 here. We're going to find our first term or find our A1. How can I use that information to find A1? Alex?
Work backwards from it?
We are going to work backwards.
Like the difference between each one?
Oh, so I'm going to try to talk out loud here. So our first term, you guys are kind of, this is great because you're making meaning of it versus memorizing formulas. So A1 here will equal, well, let's write it all out. A1 will equal, we're starting at 29, right? And then we're subtracting how many terms? 4. There's 4 terms. I'm going to say 4 terms. Multiplied by what difference? 3.5. What is it? 15. So A1 equals 15.
How do you find, do you do the same thing for like,
So now we need to find A of n. And Sarah's right. It's going to be in terms of n because you don't know what n is. Find your last term, A of n. So to figure this out, there's an equation that's A to the A of n equals your first term plus what we'll call it D, it's our common difference, times n minus 1. And if I work backwards, I'm sure we can make a connection to the rectangle. D just represents the same thing as slope. Okay? Yep, so go ahead and plug in A1 and D and then distribute. I'll have you guys do this.
11.5 3.5 n
Uh-huh.
plus 11.5.
Plus 11.5?
Maybe.
Is that?
no minus?
Plus.
No, it'd be plus. Plus.
3.5 and
Plus 11.5.
plus 11.5? Yeah, that's right. All right, box it.
Maybe second guess myself.
Good job, guys.
All right, so you have A1 and you have AN. What are you going to do with those?
Plug it into an overall equation.
Plug, substitute it into your original equation. So let's go ahead and do that now. You guys are on your way. Oh wait, we know 965, right? 965. I should say we're constructing our equation now.
So where does this go?
Do you still have room?
Yeah.
Then keep going with it. Just write small. 965 equals. We don't know n. A1 is 15, right? And then our last term, we just came up with it. Daniel, what was it?
3.5 n plus 11.5.
Okay. All divided by 2.
Why is the second one in parentheses?
This one?
Yeah.
Because this is our A of n. So I wanted to make sure you saw that this is A1 and this is AN.
Will we have to FOIL that?
All divided by 2. Before we distribute that in, how do we take care of that 2 on the bottom? I don't like it. Multiply by 2. Gone. Grab your calculators for that. We get, shoot, what is that? 1930? Now distribute the n through 3.5 n squared plus 26.5. All right, this is looking like Frank's class. N, there's an n there, thank you. What is this? This is a quadratic, right? We want to keep the n in there, but we need to set this equal to 0. So it'll be 0 equals 3.5 n squared plus 26.5 n minus 1930. You sing the song. And while you're singing the song, instead of writing the letters, you write in parentheses. So here's how it looks. X equals, oops, that's not even an X. Fail. X equals the opposite of B plus or minus square root. Can somebody help me sing? A square root of B squared minus 4AC all over 2A. Very good. Now we go back and we sing the song again. But when you sing it this time, now you go ahead and put in your coefficients or your numbers or letters. So go ahead and do that.
They just memorize 1.5. Memorize early.
If I really knew noticing it, I don't know.
If I knew it, I still wouldn't think.
Make sure you get a 1930 on this last one. All over 2a. And a is 3.5 here. Okay, now here's where you're going to want to reach for your calculator. First one is 20, right? And the second one is negative 27 point, what is it, 5 or something?
570.
Yeah, so what in the world are we solving for? If we go back to our original problem, how many terms, right? What's the only answer that makes sense? 20 terms. We can't have negative and we can't have half a term, right? So your answer is 20 terms.